In this video, I'm going to talk about temperature-dependent resistors and superconductors. First, let's talk about temperature-dependent resistors. So, like all resistors, they transform electrical energy into thermal energy, but unlike temperature-independent resistors, their resistance is determined by temperature as well as the material and the physical dimensions of the resistor. And you can see that in the formula here, R for resistance, and there's a linear relationship with T over here. It's linear because, of course, these are both to the first power. So we can see the resistance depends on the temperature. And there are other variables here. R naught, this is the resistance measured at this temperature T naught. Okay. So that's a measurement that has to be made at some point, and that's how you get R naught. Alpha, this is the temperature coefficient. It's determined by the material, and it is also measured at a specific temperature. Specifically, it's measured at T naught. So both R naught and alpha are measured at T naught. So sometimes they'll say, oh, alpha equals 0.005 inverse Kelvin at 20 degrees Celsius. Okay, well, that's telling you right there that T naught is 20 degrees Celsius. And often in these measurements, T naught is 20 degrees Celsius, but it doesn't have to be. It could be any temperature. Again, it's just the temperature that alpha is measured at and R naught is measured at. Now, let's also talk about superconductors. Superconductors are a class of materials that have no resistance. And as such, they are not going to generate any thermal energy. The thing about superconductors is materials that can be superconducting only become superconducting below a certain temperature. For example, lead becomes a superconductor at 7 Kelvin or less. So at 8 Kelvin, it's not a superconductor. It still has resistance. But at 7 Kelvin, 6 Kelvin, 5 Kelvin, it's a superconductor. It doesn't have any resistance. Superconductors have a lot of potential for our society because right now, all of our wires have resistance, and all sorts of materials that we use in our electronic devices have resistance. And so consequently, they are generating thermal energy. They're generating heat. We don't want them to. That just means they require more energy to use because of these thermal losses. We don't want those. If we had superconductors, then we wouldn't have these thermal losses. We wouldn't need as much electricity to run our devices. But again, superconductors only exist at low temperatures. They don't yet exist at what we would call room temperatures. So it's something that there's a lot of research is being done on, but right now they only exist at low temperatures. We can still get some practical uses out of superconductors, but not in everyday devices that everybody has.